Welcome to Learner's Planet, Theory Session 8 of Carbon and its Compounds. In our previous session, we were discussing about the properties of carbon and its compounds. So, we discussed the combustion of carbon compounds. In this session, we will be discussing about few more properties or the chemical properties of carbon and its compounds and their reactions. Like addition reaction, substitution reaction and their oxidation. Now let's start first with the oxidation reaction. So what is oxidation? Oxidation is what? Addition of oxygen. So carbon compounds can be easily oxidized on combustion. I told you what is combustion? Combustion is burning of a substance in air is combustion. Now these carbon compounds get oxidized. Carbon undergoes oxidation by combining with oxygen at higher temperatures to form oxides. Carbon monoxide is formed when incomplete combustion of carbon or hydrocarbons take place. So, when there is incomplete combustion means when it is taking place in the presence of insufficient oxygen. Then what happens? That carbon monoxide is formed. Same is the case with, as here is the example of carbon, same is the case with the alkanes or alkenes. On incomplete combustion or in the absence of sufficient or when insufficient oxygen is present, what happens? The carbon monoxide is formed. Now students, what happens on complete combustion? When ample amount of oxygen is present, then what happens? When ample amount of oxygen is present, carbon dioxide is formed. When complete combustion of carbon or a hydrocarbon or hydrocarbons takes place. Like hydrocarbon, like methane. Methane undergoes complete combustion or in the presence of large amount of oxygen. What it forms? Carbon dioxide and water. But had this been oxygen, had this oxygen been insufficient or less, what would have been the product? Carbon monoxide. Now this carbon reacts with oxygen or ample amount of oxygen and it forms what? Carbon dioxide, and large amount of heat is released. Likewise, carbon monoxide also reacts with oxygen, giving what? Carbon dioxide. So, on complete oxidation, what is the product formed? It is carbon dioxide. Let's take up the next property, that is addition reaction, or the next reaction which hydrocarbons undergo. Addition reaction. Reaction in which unsaturated hydrocarbon combines with another substance to give a single product is called addition reaction. It is just a combination reaction. Now unsaturated hydrocarbon means what type of bonds would have been present there? Double bond or triple bond. So when they are combining with either hydrogen or hydrochloric acid or water, what will be formed is a single product would be formed, and the reaction is called as addition reaction. Carbon compounds containing double bonds like alkenes readily undergo addition reactions. Now let's take up its example. This is what, students? It is ethene, as it has got two carbon atoms. So what would be the root word here? The root word here would be eth. So it is eth, and there is a double bond. So what would be the primary suffix? Ene. So it is ethene. Now there is a reaction with bromine, Br2. What is happening? That a new product is formed, that is this addition product is formed. Br and Br. Now what will be its name, students? What would be its name? This is an addition product which is formed. So let's write its name. First of all, how many carbon atoms are there? 1 and 2. So what would be the root word here? We are doing this name. So the root word would be eth. Okay. What type of bonds are there between carbon atoms? Single. So your primary suffix would be ane. Now what are the substituents here? The substituents are bromides or bromine. So what would be the prefix here? What you'll have to tell here is, you'll have to tell the positions also, 1 and 2. Okay, so this would be 1, 2, dibromo would be what? The suffix, or sorry, the prefix. So what would be the name of this addition product? So the name of the addition product would be 1, 2, dibromo ethane. Okay, so it will be 1,2-dibromo ethane. This is the addition product formed. There is another example of addition here, that is CH3CHO. What is the CH3CHO? Now what is the group present here? It is an aldehyde group. So what is the suffix for aldehyde group? It is al. How many carbon atoms are there? 2. What would be the root word? Eth. What type of bonds are there? Single bond. So it would be ane. Now what will be a final name of the compound? It would be ethanol. Now this ethanol is reacting with what? HCN. HCN is hydrogen cyanide or hydrocyanic acid, and the additions are taking place like this. Now there is one question, why not OCN? Why not the product like this? Is a very basic question which would have arisen in your mind, that ma'am, why we can't write the product as OCN and H and CH3. Why we can't write this product? This is a wrong product. Why? Because students, what happens that in HCN, this is an ionic compound, and your HCN dissociates to form H plus and Cn minus ions. Now what type of ions I am getting here? I am getting this H plus and Cn minus. Now what is the charge on cyanide? It is minus. How can it combine with oxygen, which is again a minus, or which is again electronegative? So that's why this type of reaction or this type of product is formed. Oxygen is electronegative, so it will combine with hydrogen, which is positive. Likewise, your Cn is negative, so it will form bond with carbon. So this is one of the example of addition reaction. I'll give you few more examples of addition reaction so that it's clear to you. This unsaturated compounds undergo addition, because in saturated compounds there is no scope of any other element or atom, because in saturated compounds the carbon is tetravalent, whereas in unsaturated compounds the carbon is trivalent. Now, no, it is tetravalent, but it has got a double bond there. Right, tetravalent, it is tetravalent in your unsaturated compounds also, but there are double bonds. So to resolve those double bonds, they undergo addition reactions. Like this CH2, there is a double bond here. This CH2, this is what? This is ethene. Now, if I am treating this with hydrochloric acid, what would be the product form? This will again give you an addition product, that is CH2, one would be H, a single bond, CH2 and Cl. Shall I draw its structure? It would be C. What all are the things here? Hydrogen, hydrogen, hydrogen. This would be again hydrogen, Cl and hydrogen. So this would be the product formed. What would be its name, students? What it would be? I told you how to number. The carbon atom to which there is a substituent is numbered 1. This is the second carbon. So its common name would be ethyl chloride, but its IUPAC name would be chloroethane. Why? As chlorine is present on the first carbon, if I am not numbering also, it doesn't matter. I'll give you one more example of this. Like your CH2 double bond CH2, this reacts with water in the presence of small amount of sulfuric acid. Okay, so it is very small amount. What it will do? This will form CH3 CHOH. So what is happening here? It is CH H, this is what? This is ethene. Okay, now I'm adding water molecule. Your water molecule dissociates into H plus of OH minus, and then it gives you the addition product. So for you there is no need to mug up these reactions. I have given these examples so that the concept of addition reactions is clear to you. So this is OH. What is this? This is an ethene. And this is what? This is ethanol. So these are few addition reactions. So these are the examples of addition reaction. There is one more example of addition reaction here. The addition of hydrogen to an unsaturated hydrocarbon to obtain a saturated hydrocarbon is called hydrogenation. So what is being done here? Unsaturated hydrocarbon is ethene. To this, what is happening? Hydrogen is added. And what are the catalysts here? Nickel at 300 degrees centigrade. And it is forming what? It is forming ethane, which is a saturated compound. The addition of hydrogen to unsaturated hydrocarbon can be done in the presence of catalysts such as nickel or palladium or platinum. So, any of these compounds can be taken to add hydrogen to an unsaturated hydrocarbon. Like here, vegetable oils generally have long unsaturated hydrocarbon chains, right, containing double bonds. So what happens? These vegetable oils undergo hydrogenation in the presence of nickel, platinum or palladium to form saturated product called vegetable ghee or vanaspati ghee, which are semi-solid at room temperature. So these oils are what? These are liquids at room temperature, whereas the semi-solid ghee is a semi-solid. Why? Because it has what? Saturated carbon chain, or there are no double bonds. Whereas in oils there are double bonds between the carbon atoms. Now let's take up another type of reaction, that is a substitution reaction. Now what do you mean by a substitution reaction? What it is that one atom is substituted by the other. The reactions which we used to call displacement. Now here what is happening? They are not they are replaced. This is substituted. The reaction in which one or more hydrogen atoms of hydrocarbon are replaced by some other atoms, like chlorine is a substitution reaction. Now this is not necessary that hydrogen is replaced. There can be any other atom also, like chlorine or like bromine, that can also be replaced. Substitution reactions are the characteristic property of saturated hydrocarbons. Saturated means a hydrocarbon in which carbon has 4 bonds. Now that is a characteristic property of saturated. Now in unsaturated there are double bonds, so nothing can be substituted there. Their addition reaction will take place. So keep in mind, unsaturated hydrocarbons undergo what? Addition reactions. Saturated hydrocarbons undergo substitution reactions. Substitution reactions are characteristic property of saturated hydrocarbons. There is an example of it. In the presence of sunlight, hydrogen of alkanes is substituted by chlorine. Let's see this example. Methane, that is CH4. When it is treated with chlorine, and here what is essential, students? The essential part here is sunlight. So methane reacts with chlorine in the presence of sunlight and gives what? Methyl chloride plus HCl. So what has happened here? H of methane has been replaced by chlorine. So if I take another example, that is of some other alkane, let's take propane. What is the formula of propane? It is C3H8. Now if I treat this with chlorine in the presence of sunlight, do remember this, that the reaction of alkane with halogen takes place in the presence of sunlight only. So this reaction is carried out in the presence of sunlight. And what it is going to give us? It will give C3H7Cl plus of HCl. So this is also what? Substitution reaction, and it takes place in the presence of sunlight. There is another example here, that is iodide of alkyl iodide is substituted by hydroxyl group, right? Of what? Of potassium hydroxide. Is substituted by hydroxyl group on reaction with aqueous potassium hydroxide. So we'll write it here, on reaction with, on its reaction with aqueous potassium hydroxide. Remember, it is aqueous, so it is with aqueous. So what is happening here, students? The hydroxyl of potassium hydroxide replaces iodine present in alkyl iodide. And what is the byproduct here? Our byproduct is potassium iodide. So this is also one of the substitution reaction. I'll give you example of this. Few more examples we'll discuss. Okay, substitution reaction. See, substitution reactions are carried out very easily with alkyl halides. If we have to carry out with alkanes, a very high temperature is required. Say for example, if I am taking ethane, that is what? CH3CH3. This is what? Ethane, C2H6. If I have to treat it with potassium nitrate, or I have to substitute this nitro group, or I have to substitute some other group here like alcohol or nitro group, what I have to do is a high temperature is required here. That is, what is used is fuming nitric acid. It's not potassium nitrate, it is done by fuming nitric acid. So in the presence of fuming nitric acid, fuming, that is, which has got very high temperature, it will form what? CH3CH2NO2. So what it is nitroethane. Like similarly, if I have to substitute a group in alkyl halide, say I am taking this C2H5Cl, what would be its structure? It would be, I'll not draw the complete, I'll write it like this. So what I can do here is, we will simply treat it with potassium nitrate or silver nitrate, and we will get our nitroethane. Okay, so if here I am treating it with potassium nitrate, KNO2, so what it will form? We will get ethyl nitrite, C2H5ONO. Likewise, if I am treating this ethyl chloride with silver nitrate, so what would be the product formed here? It would be nitroethane, that is C2H5NO2. Again, what is happening here? And we will get AgCl. Now in this case, this is ethyl nitrite. Here nitrate is also formed, nitroethane is also formed. It's a mixture actually, and this is what? Nitroethane. So here at this point you don't go deep into this chemistry. I was just explaining you how other substitution reactions take place. So you can just find out that, you can just conclude here that the substitution reactions are easy in alkyl halides, whereas they are difficult in saturated alkanes. So these were few examples of substitution reactions. So now I'll conclude this lecture as we have discussed the chemical properties of the hydrocarbons. In the next session we will be discussing the properties of ethanol, or the chemical structure, the physical and the chemical properties of ethanol. So thank you very much for your patience.